Hello.
Is it me you're looking for?
Yes, it is you. I am looking for. All right, you guys. So now this is going to be 8.2 more calculus. We left off on just basically doing some definitions yesterday. We got to go through and try and get some more stuff out of the way. So we also have a afternoon class today that I'm hoping everyone will be there, even the burger flipper, because it's not the same without him. Anyway, so let's go ahead. So now from here, diverges, infinite series, harmonic. Okay, find the sum of a series. Okay, so for this one right here, it's going to be my values. So as I do this, as I enter this right here, it's going to be, keep putting in my numbers. So it's going to be 1/2. Okay, this is 1/6. This is 1/12. As you keep going, it's getting smaller and smaller and smaller for each one. It's kind of like that square that I had that was getting smaller and smaller parts. Now, it's approaching a number, but it's never going to get to that number. So for on this one right here, we're going to set this up. So using sequence of partial sums. Where is right? Okay, so we're going to set it up just like this one right here. So we're going to have sums of this one. So from here, I need to actually break up this problem to be able to do it. Gotta make sure to find this one right. All right, so now we're going to change. We're going to change my k's to n's. So change the k's to n's, and so now we're going to take to do the limit of this. So from here, I'm going to, did I already give you the one that's already 1 minus? Yeah. So it's going to be the limit minus the s of n, right? Okay, so it's the limit minus the s of n. So it's going to be as the limit as n goes to infinity. I can't remember if I gave this one to you already or I didn't. And it was 1 minus s of n, right? Would equal the, oh, capital S. Do you remember this one? Because I know we did a problem like this somewhere.
Yeah.
Yes? Seems familiar? Yes or no?
Hopefully.
Okay, good. So yes. So now from here, I'm actually going to start plugging in from the s of n. So I'm going to get this. I need to get this to be in my n format. So I'm going to do my break it up. So this is going to be over my insert page. So I have to make this. So it was 1 over n quantity, n plus 1, right? Okay, it's going to be equal to a over n plus b over n plus 1. I've been reading through these notes so much, so I can't remember which ones I did in class and which one I was just like doing on my own, going over my notes. Yes? No? Maybe. Does this look familiar? Somewhat look familiar, right?
Yeah.
Okay, good. All right, so now we're going to break this up. So this is going to turn into 1 equals a of n plus 1 plus b of n. So on this case right here, I have this going to be 0 equals a of n, right? A of n plus b of n. And then I'm going to have 1 is equal to what? A. All right? So it's going to be, because it's 0 in, right here, got to make sure I put that right. 0 n. Because in this case it was plus 0 n plus 0 n squared. So right here, it's going to be, now, for this case right here, it's going to be, let's see, if a is 1, right? So a equals 1, because that's the only value I'm going to have. So now it's going to be 0 equals 1, right? Plus b, subtract 1, so b equals -1. Okay, so now let's take it out. And I'm going to have a, which is 1 over n, minus 1 over n plus 1. So now, I've been able to break that up into my different parts. Yes?
Yep.
Okay, good. So if I look at this, insert page after. So I have n, oh crap. Oh, I'm sorry, YouTube. Alright, 1 over n minus 1 over n plus 1, and this is my s of n. It's going to be that. And so now from there, okay, if I start plugging in the numbers for this, okay, I come up with, there's my, 1 over 1, right? 1 over 1. And then minus is going to be 1 over 2, right?
Yeah.
Okay, so this is 1 minus, so this is 1 minus 1/2, which gives me 1/2. So as I go back to my pattern here, it still works out, right? So there's my 1/2, so that's my first term. The next term came out to be 1 over 6, right? Mm-hmm. Okay, so as I keep going in like that, it's still working out for this. Come on now. Come on. All right, so from what I have, so if I continue the pattern of this, as I keep going, it's always, so this next one's going to be, so if I look at it, it's going to look like this. So it's going to be 1 minus 1/2 is my first one, right? Plus, what's my next one? -1/2 minus,
Yeah. -1/2.
that's going to be what? Oh wait, sorry, this is positive, sorry. And this is going to be 1/3, right?
Yeah.
Okay. Plus 1/3 minus, that's going to be 1/4, right? And so as I keep going all the way to infinity, as I add the sums of these up, so let's if I look at this, it's going to be, what's going to happen is there's a neat little thing that's happening right here. What's happening here? What's happening here? So what should happen every single time in between? All the way until some number, right? The n, right? So it's going to be basically, but nothing's going to cancel out this 1, is it? Nope, nothing's going to cancel out this 1. So nothing's going to cancel that. So my actual, as I take this, that I'm going to do the limit of, it's going to be 1, and then it's going to be minus my 1 over n plus 1. Yes, okay. Now, so we're taking of this because I'm eventually going to go, I just keep going, right? Because everything with my first term is always going to cancel out because it's the one from the previous term, right? as I go in infinity, that pattern continues on and on and on. And so I'm left with this at the end of whichever term I'm going to have, right? And so from here, I could actually figure it out. I'm like, hey, how would I figure out the 10th term? Wouldn't you just put in 10 here? Because if all these ones in between are going to cancel out, right?
Only the last one matters.
Only the last one matters in that one. And so figuring this out, I could plug it in and say, hey, can you tell me S of 10? Okay, so it's going to be 1 minus 1 over 11, isn't it? Which is going to give me a decimal that's coming closer and closer to my limit, which was 1. So mathematically, this is... Does this make more sense now? Or are you just like shaking your head because you're like, oh, what the hell? Patro's still on a rant. Please don't look at me. Don't call on me. Are we okay? Because this one is nice. It worked out really pretty.
Yeah.
Questions? That guy.
I don't have a question. It's just I get it, but I don't get it.
Okay, so now let's pretend like you're in some guy's pre-calculus calculus block, and you have to do that factoring triangle thing to actually figure out the nth term of some thing. So you're gonna have some polynomial, right? So you're gonna say, hey, what is like, I think it was like x to the 5th power, and you would say, hey, what's the 5th term in this polynomial? Remember, there's that triangle that you make out of this. Yes, and it branches off. No? You guys didn't have that?
I don't know.
Oh, I know what you're talking about, but no, I don't know what you're talking about. It's a faint image.
All right, so your answers come out to be 1, then it's 1 plus 1, and then it's going to be 1 plus 1 is 2. This is, actually it goes this way, so is this going to be, this one's 1, this one's 2, and this one is 1. And then as it keeps going, it talks about your polynomials. So now so my third, so this is going to be my trinomial off of this. It's going to have a coefficient of 1 here. My middle term is going to have a coefficient of 2. And my last term has going to coefficient of 1. Did I just like blow your mind because like voodoo magic?
I think it's wrong because the first one is 0, 1, and 2.
0?
Yeah, it would be like the exponent would be 0, and so you should.
Okay,
go
so
one
anything
0.
to the 0 power is.
Yes, but like 1, 2, and 1 are for the second grade, not for the third.
All right, so a third degree would be a binomial times a binomial, right? That gives me a trinomial, right? Right?
No, wait, this is a second.
This is right here. This is my third. Because it's going to have 3 terms. It's not the
It's not the power.
it's not the power, it's just the terms. It's second degree would be here on this line right here, right? But it is 3 terms.
Are you sure? Isn't it that second degree?
Yes, this is second degree. Second degree, 3 terms.
Yeah, but you wrote to the third.
This is, I know, but there's still one more. I didn't do that last one.
Ah, okay, sorry.
Do you want me to do the next one?
Yeah.
I can do the next one. The next one's going to be, let me see, that's going to be 1, that's going to be 3, and 1. So that's actually like that. So without actually having to do all the math, I know it's going to be x to the third plus 3x squared plus 3x plus 1. Make sense?
Sure.
I think you guys missed out on all kinds of fun stuff.
Yeah, we did.
What happened
We really
to
did.
it was 7 years of math.
No wonder.
Okay, so let's go back. What was the? So you're saying I get it, but you're like, is it more of a why?
It's sort of like a why. So like we started out with the summation, all that fun stuff, and stuff was happening. It was getting smaller, still equaling to 1.
Okay, but
And
now,
we broke it up into parts.
okay, so now what that's actually doing is going back to this square right here. Okay, so as I did it, I have my half, right? So my item here is a 1 by 1 square, which I know that is 1 unit square, right? So I took this half plus a quarter. This is like Fibonacci here. Okay, this is just like Fibonacci sequence. This is the golden ratio here. So as we do, okay, it goes here, 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 right? Here, here. So it just keeps getting smaller. So each one, as I cut each one in half, and then I cut the other half of that in half. Okay, so now here's a really, really good analogy. The distance from this wall to that wall. Okay? I'm going to go half the distance the first time, right? So, all right, walk, right about here. Okay. Okay. So now I'm here, right? So now, next I'm going to go half the distance to the wall again. I'm going half the distance. Half the distance. Half the distance.
Stop with the simulation.
And you'll never get there because it's infinite.
Yes,
But
and
you're-
so as I take the infinite amount of sums, it's approaching the number, the whole number of what my limit actually is. So as my infinite amount of sums, so I'm adding an infinite amount. So I'm actually keep doing this to infinity. And so what is it I'm approaching as I'm getting to infinity? Right here, I'm approaching my door. In this case right here, I'm approaching the number 1. It's getting, the step is getting smaller and smaller. If you notice right here, the step is getting smaller and smaller as I keep adding. So I added, so there's my half, quarter, 8, 16, 32nd. Next one would be 64th, right? Then 128th, then 256, then 512. It's going to keep going half and half and half and half and half. But as my numbers, if you notice, as my numbers keep adding up right here, if you look at my decimals, it's getting closer and closer to 1. And that's what I'm showing as I take the limit to infinity. Okay, that's the concept. Now, what I did mathematically here, is I broke it up into parts because I have more than one variable here. I have a k here and a k there. Okay, that's what I'm coming up with. And so given that much information, I'm able to do what I had here. So I broke it up into my sequences, right? I broke it up into my sequences, and then from here, I actually did, okay, I broke it up into here, so I now have 2 fractions for this. I broke those up using crap, the word just lost me. Partial fraction? Yes, partial fraction. Yeah, partial fraction here. And so, are we okay with the partial fraction? Or no? Yes? Maybe?
No, yeah, I don't think he was there for 7.5.
Yeah,
So
he-
that was
yeah.
very,
I did it on the chess sort
Oh, okay. So, but what was it okay or is it?
I just wasn't using the right numbers.
Okay, so one of the big key things that we did in class when I was going over it is when I started writing it out like this, then it was like oh, it's an aha now. It's an aha. So I'm gonna, you know what, just for the sake of, just for the sake of. Okay, so what I'm going to do is I'm going to multiply everything by the common denominator. The common denominator is going to be n quantity n plus 1. So n quantity n plus 1. Okay? N quantity n plus 1. So as I distribute here, that's going to cancel out all that. So I get 1. Okay? So that is just a constant one. There is no variable there, right? That's the one that's a constant. Equals. Now, as I distribute here, what does it have? It has an n in the denominator, right? So I'm going to cancel that when I distribute. But then that means I still have to distribute the n plus 1. So I'm going to get a times a quantity of n plus 1. Yeah? Okay, so now when I distribute here, it has an n plus 1 already, so it's missing the n, isn't it? So it's missing an n. So now, plus b times n. Okay? So yeah, we're good. Now, I'm going to do a little distribution. So I'm going to write out all my terms that I have over here also. But if you notice, there is no, over here when I distribute this, it's going to be a to the a times n plus a plus b n. So now that these are going to be first degrees, right? That's first degree, right? So over here on the left-hand side, I have a 1, which is my constant. Yes? But I also have a first degree. I do, but it's a 0. So that's where I put plus 0n. It's there, but I have 0n. So there is my number that I've been looking for. So right here, when I do my degrees, because the sum of these has to equal those over there. So altogether, when I add them all up, I know that I'm going to have 0n here. Because when I add together a n plus b n, that has to equal 0. So on this side, that's where it comes out. And then, what about constants? There's only one constant here, right? So now I get 1 is equal to a. That is helpful here. That's super helpful. So now, when I set this out, so I have 0n equals a n plus b n. Divide everything by n, right? Divide everything by n. So now I'm still going to have 0 equals a plus b, right? And I know that a is 1, right? For a to be 1, 0 equals 1 plus b. So therefore, I get b is equal to negative 1. And all of this is to set up my partial fractions. I need to set up my partial fractions to be 2 separate ones for this. Or if possible, more than that. But I don't want to. All right, so I'm just trying to do that piece right there, okay? So just from there, I'm going to use that. So my partial fractions now up here that I have in red, my a value was 1 and my b value was negative 1. Does that make sense now from there? So is that part helpful?
Yeah.
Okay, so now, do you understand what I'm trying to do here on this next page?
So they cancel out.
Yeah, all your middle terms. So now, every time I plug in 1, so I plug in my number, the numerical value that I'm looking for, right? So if I did not have this broken up and I say, hey, what would be the 10th term? By looking at this right here, and you're like, huh, what would be the value of the 10th term here? So if I take n is equal to 10, so S of 10, that's a 10. All right, so I want to know the value. So I did this previous right here. Right here. This one right here came out to be the, let me see, 1, 2, 3, 4, 5. The 5th term. Okay? The 5th term, the sum of the 5th number is here. And that's where I was getting at. Sum of the 5th one comes there. So it's getting closer and closer to my limit, which was 1, right? Okay, so now you feel better?
Yeah, so there was, the part that I'm like confused with is the 1 minus 1 over n plus 1.
Okay, so here's my math. So as I keep going, you understand that this comes out to be, eventually, it's going to be 1, it's minus my, this part over here, which is 1 over n plus 1. Okay, the reason why it's doing that is because it's canceling out everything in the middle, right? If it cancels out everything in the middle, so depending on what number I'm going for, so if I say, hey, what would be the 10th one? So all of these middle terms is going to cancel out, right? From here to here. So all these cancel out. So the only one that's not going to cancel out would be my last one and my first one. Because I'm subtracting it here and I'm adding it on the next one. Subtraction, addition, subtraction, addition. And then my last one, which it'd be my 10th one in the case that I'm asking for, this would be, there's not going to be another addition on top of that. Okay, so this right here, so if I say, hey, now S of 10 would be, it would be right here, it's 1 minus 1 over 11, which mathematically comes out to ugly. I don't know. You guys already got it, or no? Okay, so there we go. 0.9090. You know, it's basically just repeating, right? 9 zeros repeating. Yeah?
Yeah.
So it's getting close to the numerical value of 1, isn't it? So as I keep going, it gets closer and closer and closer to that 1. So now, that's what I was asking for. All right, so what's the 10th iteration? What's the 10th number of this? Already?
It's early for that.
I know, man. Anyway, does that make sense? And so that's why after doing all of this, my middle terms cancel, and I'm left with just that right there.
Now,
Okay, now that asks for the number. So now what I'm going to do is I'm going to take that same value, the same thing this time, but instead of putting a numerical value there, I'm going to say I'm going to take the limit as n goes to infinity. Right? So let's break up my limits. So it's basically going to be the limit as n goes to infinity of 1 plus the limit as n goes to infinity of 1 over negative 1 over, that should be minus, right? Either way, it's still going to work. N plus 1. Limit as n goes to infinity of 1 is just 1, right? The limit as n goes to infinity of negative 1 over n plus 1 is 0. So as I take this limit to infinity, my answer is 1. That's how we're doing it. That's how we actually come up with what it's going to end up at. If you notice, in this case right here, it said, show that it's equal to this. Show that it's equal to this. Sometimes you're not even going to know what it's supposed to end up at. You just know that, okay, there's going to be some limit. It's going to be some monotonic, limit that does converge to a number. Okay? Happy now? Super good. All right, so now, how about this one? Show that this one diverges. Okay, didn't we have one like this? Okay, was there a test for this one? Was it on this one or was it on the previous set of notes?
Previously.
The previous set?
I thought so, yeah.
Yeah. Okay. I will open that one just for this. File. Open. Ah, crap.
That one.
Keep missing it. There it is. Convergence, divergence of a geometric sequence. Converges to 0 if, so this is r to the n, right? R to the n, where r is a real number, where n is the sequence it's going to, right? The number, okay, the term for this. So it converges to 1 if r is equal to 1. Diverges for all other numbers. So, in my case right here, it's got to be between -1 and 1. There we go. So, did I go too far? Oh, there it is right there. So, right here, I should be, and my -1, which is my r value, and then between 1 for this one. Yes? So, in this case right here, is this one going to converge to 0? Say no. It does not converge to 0 because this piece right here is not supposed to be equal, right? Is not supposed to be equal. So in this case right here, this one is going to diverge, okay? Using the test for geometric sequences series. So this one is going to be diverges. Oh man, today's going to be a long, long day. I have to listen to that thing all day. Man, starting at 9:20, man, that's messed up. Huh?
Was it just me or was there?
Yeah,
quieter
it's
before? Like
so
when it
odd.
started, it was quiet.
Like a bees,
Like
like, right next to the
it
mic.
It sounds like somebody's like.
No. It like starts ramping up at a certain point.
What is it for?
Okay. Alright, so this one right here. Determine whether the series converges or diverges. Okay, let's pay attention. In this case right here, this is just going to be one of those terms that is going to be just a S of n, right?
Yeah.
So this would be just an S of n type of problem. So for this one right here, remember what's got to happen for it to, there was another test for this one where it was trying to find. Oh. thought there was another test for this one, or did I already go through it? Did I miss that one? Because there was an actual example that specifically said just an S of n. Can't remember which one it was on. Okay. Anyway, so in this case right here, my value would be just S of n, right? So it would be S of n of my just n, right? So it's going to be in my series. I go 1, 2, 3. Now, is this one right here ever going to converge to anything?
No.
So in my terms, as I take the sum of this infinite sums, so the limit, so I'm taking the limit as n goes to infinity of n, that's going to go to infinity. So therefore it is divergent. Oh, happy day. Okay. All right, so analyze a geometric series. Okay, geometric series occur in large variety of applications, including biology, finance, probability. They're also useful for analyzing other infinite series. In a geometric series, the ratio r, any two consecutive terms, is a fixed real number. Two terms, fixed real number. So it's basically, if I do my first one where a is not equal to 0, because anything times 0 is, thank you. All right, so in this case, it's eventually a is going to be my first one because it's going to be the k minus 1. If you notice, because right here I'm starting at 0, right? Yes? So, because of that, then it goes into where k has to be equal to 1 here. Okay, k is equal to 1. I can't start with this one being 0 for this. So, it's going to look like this. K minus 1. So, I start off this at k being the terms. So, that would be the n, or n, you know, as I go, where, remember my n's, my counting numbers, has to start at 1, right? It's greater than or equal to 1. Okay, theorem, convergence of a geometric series. Okay, absolute value of r is less than 1. The geometric series converges, and its sum is going to be, look just like this. If the absolute value of r is greater than or equal to 1, the geometric series is going to diverge. Woo. Ah, yes. Okay. All right, so we got a crap load of this. I think I'm gonna hit this up this afternoon. Okay, cause yeah. All right, like, share, subscribe.